Hello.
Hey, this is Jeff.
Hey, Anu. This is Yuni.
Hi, Yuni.
Hello?
Hello.
Hi, this is Nansu.
Hi, Nancy.
Hi, this is Ron.
Hi, Ron. Just wait for a couple of minutes.
Hi, this is Wei Wei.
Hi, Wei.
Hey, Anu.
So hi everybody. Let's get started since we have a fairly full agenda today. So let me just start off with calling out the names of everybody on the call. I have Trevor, Edson, Riling, Shaoling, and Hua here in the room with me. And on the call, we have Dave, Huni, Jeff and Yuling, Nansu, Ron, Todd, and Wei Wei. Is there anybody that I missed? Okay, if not, so let's move on. So today, after going over the action items very briefly, we'll have Jeff presenting on the reindexing run that they did. And then Jeff, Burak, Riling, Shaoling, and I had a meeting last week. So we'll report on what we talked about in that meeting with regard to the way we'll have flow of information between the UT Health team and Jeff's team for updating on indices. We also talked about test and verification procedures that we plan to have in place, and that actually folds into the workflow outline. And then Shaoling has some results from the data med evaluation that we did, so we'll talk about that. As earlier, we have the help and FAQ page, which is available in the Google folder that we have for the CDT. So please do get in there and provide any input. Also, we will, once the NLP pipeline is finalized, Jeff and his team will be doing a complete reindexing with the updated NLP pipeline. I just want to have it in there because we'll get to it later. And the testing for the new version, which will be version 2.0, is expected to begin on February 16th. So we had a meeting with the Links folks yesterday where they're working on the visualization supplement that Lynx and BioCaddy has together. The Chrome plugin that is being developed from by the Lynx by the Lynx group is complete, and they will present their work at the CDT meeting next week. Xiaochen also has a prototype for the geolocation, and he will be presenting his work as well. With that, it's all yours, Jeff. Do you want me to make you a presenter, or you want?
You can just go through the slides. It's fine.
Okay.
So go to the next slide. Oops, the slides shifted a little bit, but the basic overview of the process. So there were all the current sources that we had already indexed, so that includes 58. And so again, these are indexed ones. They might not be in the 1.5 release. So these were the repositories that we had indexed. We ran all sources through sort of in batch in a sequential order, and this utilized our one development node for processing that we have on AWS. This was as we described before, this was a reindexing process. So this was actually the reindexing, not a complete update. So this was a reindexing process where we added new data. So basically, as documents come in, we check to see if the document is the same as what we already indexed, and if there are no changes, we leave it alone. If it is new or updated, we reindex it. And so again, this is sort of the testing of the updating functionality. To the next slide.
So when you say updated, that means you're checking each of the fields?
Yeah, we're checking the whole document. So basically, we check the original doc. We have a copy of the transformed original document, transformation is a bad word there. So when we bring in a document, we convert to JSON. So our internal format of any document from the outside is JSON version of that. We store the original. When we bring in on an update, we bring in that same document. We then check to see, is the document that we just pulled the same as the old one? If they are the same, we leave it alone. If there's any difference in the document, we reprocess. Does that make sense? Okay. And so as we mentioned last week, there's a Google Doc that had the listing of all the sources. If you want to look at it, it also has links to the index data. Keep on going to the next slide. So the overall statistics, the total number of metadata records that we processed was 77 million. So again, sorry for the misalignment of the slides. I think I had mine set out in the larger HD format, so it went compressed it. It messed up the layout. So that's approximately 3 times the size of PubMed. Hold on, I can't see what the number is. So the average record size, so in terms of the size of the metadata records that we're processing, they average around 1 kilobyte. Sorry, I'm trying to find so I can read that number that's behind the graph. The median document size is about 3 kilobytes, and the largest document size in terms of sources was 3.4 megabytes. And the total size of the metadata that that was indexed was 68 gigabytes. So that's sort of an overview of sort of what was actually processed. If you go to the next slide. Okay, we had a large variety of sources. So actually, there's one source which is very large. That's Unipro Tremble. So Unipro has two sources. They have SwissPro and Tremble. SwissPro is their highly curated data set. Tremble is their sort of more automated curated set. So Tremble is the largest source we have with 74 million records. And we utilized basically all the different connectors that we have in terms of how we can actually pull in data from sources. So everything from rsync, FTP, Web, Aspera, and others. Next slide. Okay, and so the total ingestion time, again, this is on a single node running sequentially, was just over 23 hours. And that's for the 77 million records. And this did not include data download time. Okay, so this is something that in terms of how we were collecting timings, we never sort of thought to include the download time before, so this would be in sort of next steps, but some of these sources take a while to actually download to get from different places. And so the ingestion part of the process took about 224 documents per second. And then next slide. In terms of these timings, they're fairly, this is just a scatter plot based on number of documents and the total ingestion time. So it's a pretty well-behaved system in the sense of, it's pretty straightforward in terms of how fast the documents are processed on the ingestion side. Next slide. And then the lessons learned. So I just mentioned the download. So this was one time where since we were running them in batch and we were sort of looking at the timing, we noticed that actual document retrieval sometimes takes as long as processing. And so basically what is happening is that, as the documents are being downloaded, documents start being processed. And, the issue here is that, because it's based on a messaging queue type architecture, as the document comes in, it gets sent out to be processed already. So if the download is taking a long time, the documents can already begin processing, as the documents are coming in. And so we're going to be adding some additional sort of timers so we can actually, on the next runs, we get a better feel for, the download aspect and some of the other aspects. And this ties into some of the sort of management functions. Most of the development was focused on the actual, sort of processing, that we have to do for BioCaddy, less so in terms of what one has to do to sort of, view the process sort of as a manager as it sort of goes through in these bulk steps. And so one of the areas that we need to, that we're looking at to improve is also the counting in terms of, what is the current status, where we are in the process, the messaging system, and because many documents can be at many different stages at one time, counting is not as straightforward. And so we're looking at ways to better sort of record, where sort of the documents are in a process rather than, sort of just at begin and end, but also sort of, as things are in the middle. And with this, we can also then implement some additional timings for that. The other note is that this was run with one ingestion, one processing node. When we do the work with the NLP, we may add more processing nodes because the NLP portion does add quite a bit of processing, to a document run. And so that's one of the things that we'll sort of experiment with, when we do this, next stage with the NLP module. And the next slide. Pardon me?
So currently you had disabled the NLP pipeline completely, right?
Yes. Yeah, we disabled the NLP because there was also that memory leak that we were running
Right.
into, and running this in batch, we would run up against that issue. And then the
Sorry, Jeff, one question.
oops, go ahead.
Yeah, so I was wondering if the time that you mentioned, so the 23 hours and a half, it's for processing from scratch, right? It's not for the update, or?
That's all the documents being processed, right?
Right, yeah.
So on the ingestion.
Because you also
not the
displayed
down,
comparison between the old
Pardon me?
JSON and the new JSON.
No, these were already. So these are all repositories that we've already indexed with the new DATs. These were all the ones that we already had that were 2.1.
Yeah.
So
Okay.
again, this was just an update, of new records that came in.
Okay. So it
So
means
again,
that
this
some of
can-
the records
yeah,
may
this
have
should be
been processed.
Sorry.
Some of the records may not have been processed then in those 23 hours. Only the ones that were new. Is that right?
Yes,
or-
exactly. Yes.
Okay. Yeah.
Yeah. So again, we have the data that we have, and we're going to improve it to have more data next time. But in terms of how it operated as sort of we expected. And then, as we mentioned before, the next steps are, the full update of all records and the full update, with the NLP module. And so the question is, we'll decide, we'll figure out, depending on testing of the NLP module, if 1 and 2 are the same run, or if we do sort of 2 runs back to back at some point.
Okay, great.
So Jeff.
So,
how
so
often-
Jeff, this wasn't updating per se, but rather re-indexing.
Yeah, this was the reindex. That's the first thing we did. Yeah.
Okay. So when it's time to update, will this re-indexing be run first and then updating, or how would you propose putting that all together?
No. The update basically tells the system that all documents should be considered as new documents. So it basically does a full ingest.
Okay.
Because there, for example, that tests the case of, as said on the slide here, either an update to the transformations or updates to the ontology. Basically where we have to run through, everything, and basically redo, all the document processing.
So Jeff, based on the process that you actually just went through, how frequently do you think we need to do these updates? Or the reindex? Or could it be different for different repositories?
It could be different for different repositories. This is going to tie into the discussion we had last week, which I think is a point or two down the agenda.
Yeah.
Is how we can basically streamline this so that once we do a run, like a reindex, that it can be automatically sent to the index. Most of these, for some of the larger sources like Unipro, they're, it's more of a monthly type update. Others, sort of gather, like Figshare and others gather information as they're submitted. So again, it would be sort of a mixed use case. But in terms of the reindexing, in terms of the timings and all that, there's nothing right now with the number of sources we have, in terms of doing this at potentially regular intervals. But again, that depends on, setting up this automated pipeline that we discussed last week. Because otherwise, then just the man hours needed to do the shuttling of data back and forth to the UI becomes prohibitive, right?
Yeah. So I was also wondering if it would be useful for somebody to go through all of the resources, all of the repositories, and also figure out how often the repositories themselves update their data, right? Because that
and we actually, we do have we on our end have the prior indices available as well. We can, someone could actually go in and look at, how many, what's the change in the number of records, for example. And so when we do the next update, which will probably be, if the new NLP module is sometime this month, there's sort of going to be maybe a little over a month between the two runs. Then we can see what is the difference in the document counts between, this reindex and the next one.
Yeah.
Yeah, I'm pretty sure the NLP will slow down the system, and we probably need to consider like a multi-thread thing.
Yeah, no, that's why we're going to be running multiple processing nodes, and we'll also run Tremble last, since that's the very, very big one.
Okay. And the memory leak we look into it could be the MetaMap Lite problem.
Okay.
The MetaMap, and we already contacted the NLM folks who developed the MetaMap Lite.
Okay.
They are looking at the problem.
Yeah, no, because that's one of the things. If we run something in batch, it was causing the system to sort of hiccup and have to be restarted. Which is good because we tested our restarting capability, which works fine. But it just means that then someone has to sort of babysit the process, which isn't, which is not fruitful for that person.
Hopefully, we should be able to figure.
They are looking for that problem.
So we'll have a solution, right? Hopefully so.
Yeah.
So Jeff, do you want to talk about this? You and I think Relink can talk about.
Sure. So this is what we were talking about in terms of the current workflow. And I think we covered this in last week's meeting. So this is the current workflow where we have, the endpoint which we use for our internal purposes for testing development, and then we're pushing this to the development endpoint. This gets pushed to the development endpoint at UT Health, where work goes on to incorporate that into the DataMed prototype. And once work has gone on at UT Health, and this includes UI components, but also providing working on the Elasticsearch mapping to sort of define the fields within the data files, within the index files. This is moved to the production endpoint, and then there's also a push of code from the development endpoint to the production endpoint. So that's sort of the current development process that we've been in. And so last week we sort of talked about how we could turn the data flow into a more production-oriented flow. So I'm assuming that's the next slide?
Yeah.
Okay. And so the idea is basically to take UT Health out of the middle and put the production endpoint. So basically when we do a reindex that we directly push, as soon as a source is done reindexing or updating, we push the data to the production endpoint. But this new index will be date stamped. And so basically the UI won't notice that it's there, but the Elasticsearch will have it. So we can actually then run some automated tests. And so we started discussing last week some of the automated tests that we could do to verify if the data that was reindexed, updated, is good for production use. And one of the things that we also discussed is that since this is a prototype and there is the question of, well, are we going to be able to know if all the use cases for all the possible problems with data will be found, that we might also want to provide a dashboard for a reviewer just to see real quick how the two data sources compare with the new index and the old index. And then there's sort of a go, no-go decision. So if the testing is passed, then there's a go decision, and basically all that happens at that point is that since the new index is already on the production endpoint, all we do is change an alias. So basically there's an alias that points to the current data, and then that alias will be moved to point to the newer index. There's no movement of data or anything at that point. It's just rebending that alias to the updated data point. If there is a no-go decision, then we have to take it back and look and see what's wrong with the data on that run. But this is sort of the simplest method we came up of figuring out how to sort of transfer data directly to production on these reindex runs. And in our discussions, again, we sort of did come down to the notion that we would still need to have sort of a person in the loop at this point, just to do sort of a last second verification. But again, with more time and the ability to to see what type of differences in data we might have, rules could be instituted where this could be potentially fully automated down the road.
Okay. Are there any questions with regard to the workflow that we presented, or are there any suggestions?
Hi, Jeff. I have a question.
Yeah.
So currently, when we move the data from your server to UT server, we need to update the index, like adding the not analyzed field. So if we're using this new workflow, so we'll do add this not analyzed field.
Well, no, that's done at the that's basically the mapping that we discussed, right?
Uh-huh.
Right. And so we should be able to use the same mapping file if the transformation hasn't changed. So again, this is for the reindexing and for updates to the ontology, for example.
Okay, thank you.
So in case, this is from the previous one.
Yeah, that's the previous, yeah.
So this will be, I guess, yeah, right. It will be done automatically at the back end.
So we'll put the mapping file into like the GitHub, and then in the first
Yes.
step they will use that mapping file to do
Right.
that.
Okay.
So
I can do it if you want to. It's fine. Probably easier for you.
So we have done some evaluation on the search results from the data map. So I will present what we have got. We search results from the 43 repository in data map individually and compare the result with the primary website. And the evaluation was done between January 17th to January 31st. And for each repository, we pick one appropriate query and compare the results from both sides. What we compare the total number of data sets data map include and the primary website include. So we also compare the return result for the query from both sides. For both sides, we annotate top 10 results as relevant or not relevant. We also look into the top 10 results and see how many of them are overlapped. So here's the result overview. I will show the details of the results in the next couple of slides. So we have 19 repositories which will return similar numbers. We have 9 repositories return different numbers. And 7 repositories have a granularity problem, and we cannot compare a repository at this point. So here's the first 10 repositories which return similar numbers. Similar numbers here, I mean that the numbers are in the same scale. Like 10 and 20, I consider similar, but 10 and 200, I would say is different. And the number in the blue color is the number that DataMap, the total data set that DataMap include and the primary website include. The NA means not available because this website is not straightforward to see the total number they include. So I put the NA here. And the number in the green is the return result for the query. And the next 2 columns are the relevance of the top 10. And the last column is how many of the overlap in the top 10. So here's another 9 repositories which return similar numbers. So here we have 3 repositories with the number DataMap includes are quite different from the primary website. So we took a look into each repository and try to find the reason. So here, like the drive, we include more than 82,000, but the primary website we can only see like about 15,000. So we found that because we ingest in data package level and data file level. So basically that the data scope is different. And for example, the neural vault collection, we also index some users' temporary collection. But in their search function, they did not return the user's temporary collection.
And with Gemma, one of the issues is that they, I think, include in their index for their sources the PubMed article as well.
Okay.
So that's why there might be more hits in on the primary website because of that.
So here's the 9 repository which return different numbers. We also took into each one to try to find the reasons why the number for the query returns is quite different. So there are 3 reasons that may cause the difference. First is the search algorithm difference. We use synonyms, we extend the synonyms, the way they get the synonyms and the way to construct the query is different. And the second reason is that the data scope. For example, the CISO bank, I found that they also return results from the CISO tool, which is another big archive. And the third reason is some repository, the metadata in their website is more richer than the index we have. For example, the Swiss prot, they have the gene and protein information, so when we search this, it matches to that information, but we don't have that, so we didn't return as much as they have. And for the Morpheus Bank, when we search Lima to DataMap, we didn't return any results, but in Morpheus Bank, get results. So we found that because they match the Lima to Lima, but in DataMap we did not match to Lima. So here we need to expand the Lima to Lima by improve our terminology server. So here are the 6 repositories which have a granularity problem. So for example, the PeerJ, in their website we can only search publications, but we just index the supporting data set, so we cannot compare.
So, but is that, I mean, I mean, I don't know if that's a granularity problem, right? Because it's just that we're indexing a different part of their content, right?
Right.
Because we're
But
not
they
a
don't allow.
citation endpoint.
Yeah.
We're just indexing the data sets.
Right. So it's like for this we cannot compare like.
Right.
Right.
And like for the MPD, they can only return QTL, but we are indexed in individual mouse level, so it's different. So there are 8 repositories we cannot compare, like 5 of them because their primary website does not provide keyword search function, and the BGI is in Chinese, so we don't compare it. And for the dbGaP and SAR, our index still in the version 1.5 is quite old and is not mapped to DEX 2.1 yet. So I also didn't compare these two. So the summary is we evaluate the search result from 43 individual repositories. And for the 28 repository, we have compared and annotated the top 10. Totally, for DataMed, we annotate 193 data sets, and 188 of them are relevant. And for the primary website, we totally annotate 218 and 201 are relevant. So 3 reasons for to return different numbers, that the index scope is different, and the search algorithm is different, and the metadata in standard primary website is richer. So 7 repositories have granularity problem, and we cannot compare 8 repositories at this point. What we can do now is that we can improve our terminology server, and then we may contact some repositories for the granularity problem. So that's it.
Are there any questions or suggestions?
So what does this say about reliability of DataMed when you focus back onto the primary data sites?
So what?
What do you mean? What do you
Well,
mean by reliability?
does this speak to how reliable is the indexing of as done by DataMed, as opposed to what you could get by going to the primary source of the data?
I'm not sure if this is just show the indexing quality. This is also
I see.
the search. Yeah, so it's like indexing plus search, the whole thing. Because as you can see, the performance difference could be coming from the indexing, because we are at a different granularity level. And it also could be on the ranking, because we have different ranking algorithms. Although both top 10 like from DataMed and from original website are relevant, but those are different top 10.
Right, I think you can
That's
see that
that's
here.
called by the different ranking algorithm. Like the first
Okay.
row you see.
So
both of them
reliability
have
is, reliability then is a different question.
Yeah. So this is both of them have 10. First 10 records are relevant, but overlap between those 10 are 0. The relevant means the ranking algorithm is very different somehow, and it's hard to judge which one is better, because both of them 10 of 10 are relevant.
And also limitation is that we looked only at the top 10, right? I mean,
That's right. Yeah, we can. We don't know the record basically.
Yeah.
But
the overlap wouldn't be hard to measure.
so
Oh, you mean overlap of all the...
all the return the result.
Return
Right?
result.
Oh yeah, maybe we could do that.
But how
That's
would
another
we...
measure. Just see how many overlap.
From the primary repository, I don't know how easy it would be to...
Yeah, if they have
download the
API,
search
then
result.
will be
I
easy.
see.
If not, then
So we don't have an easy way to retrieve all the return the results from
Right.
each website.
and even if the same return the overlap, but the ranking still matters.
My feeling is I think this is definitely worth doing this kind of evaluation. At least give us some confidence, like DataMat is returning something relevant, and most of the case, if it's comparable, then they have similar performance with original website. But, in terms of next step, I'm not sure if we want to do more queries or it all depends. Like I'm also thinking about if we are thinking about writing a paper just about the DataMat, like the whole ingestion and the search, maybe we could do a little bit more evaluation.
But I wonder if the results would maybe turn up different also for those where you're saying the metadata is richer. Once you run the NP down at the back end, you probably would.
Right.
That's right.
The difference between that and this.
One question: the queries were they extracted from somewhere, or you just came up with them and ran the same one in DataMat and the original source?
So the queries, we actually pulled out commonly used queries on DataMat, and then made sure that the queries were relevant for each of the repositories that we were checking them against. So they were not necessarily one single query that were used for all the repositories, but they came out from what we had as a list of queries in DataMat that was used by the users currently. But
okay, so looking at the logs.
Yeah, exactly. But they also were just, most of them were keywords. I mean, there were probably one or two that were a couple of words, and none of them were actually a sentence, right? They were none of them were like a natural query.
Okay, and have you considered, or would it be useful to look at the competency questions we had from one of the working groups and this list that was put together at the beginning? Or?
Right.
For that, many of the repositories cannot handle such long queries. Yeah, most of them will return like 0 results.
I think we had 2 or 3 which were like from the instantiated queries that we generated as well. But as Xiaoling says, a lot of the repositories do not really give you any results.
Okay, thanks. And I guess that for that reason, DataMat wouldn't give it either, right? Or can we say in some way that the metadata has been improved? Or?
I think maybe on the query and the search capability has been improved, I guess.
Okay, thank you.
So for just to answer your question though, for comparing, so Xiaoling also did an evaluation where DataMat was compared with OmixDI Bing and Google. And there we used natural queries versus keywords. I think you did present that, but I can send that file to you if you would like, Alejandra.
Okay, yeah, please.
How it looks different, yeah. So on GitHub, we actually have about 112 open issues, and we hope to have addressed at least some of them in the next month or so. Actually, I think that's about it. If there are any other updates that we need to talk about, then we could talk about them.
Will the tutorial be ready by the launch of 2.0?
Tutorials? Maybe
Yeah,
the help menu. The help menu
well, the help,
will
the
be ready.
facts, the help, the facts,
Yeah,
and the I'm thinking of the video. Yeah.
Oh, the video, Jeff, the video has been finalized, right?
Yeah, I mean, I haven't gotten any additional feedback, so.
Yeah, so
Okay.
that's kind of fine.
And the tutorials, I mean, there we can do sort of the PowerPoint sort of, slide by slide tutorial, but we'll need the 2.0 interface to do that.
I don't know if interface-wise we don't have much difference, right?
Just the number. The landing page will be different because we have more repositories and we have that.
The home page, right?
Yeah. And also search result page.
Right.
Total number of
But
search
the
results.
layout will be different, but the number is different.
Okay. So the tutorial would be for specific use cases, right? So we might have to, I don't think, Ron, to answer your question, the tutorials probably won't be ready because we'll have to identify use cases or whether we do it function-wise and then get that done. But the help menu and the video will be ready, I think, by the time we launch 2.0.
Okay. Thank you.
And also for the usability studies, right now we have the tracking system that has been that's being tested out and will be implemented next week, and on the production end. The recruitment has been initiated for the summative testing. I haven't yet heard back about how many users have been recruited, but that's something that's ongoing. They're also doing some formative testing on the site right now. So, is there anything else? That we need to talk about today? Okay, if not, I think we're going to be done a little early today. Thank you.
All right.
Okay. Thank you.
Thanks.
Everyone.
Bye.